Alright, so here we are with rate of change and slope, and this is actually a very key term that we are going to be talking about. Slope is kind of, well, it's actually the basis of calculus, so we definitely want to make sure that we understand this. We also will be interchanging it with rate of change. So if I ever say what's the rate of growth or the rate of the difference or really anything when we talk about rate is actually referencing slope or this growth. So we're going to find rates of change and slopes, and then we're also going to relate a constant rate of change to the slope of a line. So, rate of change official definition is a ratio, which would just mean fraction, that compares the amount of change in a dependent variable to the amount of change in an independent variable. So our rate of change is in a fraction, again, the change in the dependent variable over the change in the independent variable. And what does it mean to be dependent or independent? Well, it's funny because, for instance, if we think about tax returns and things like that, if you list your dependents, that would be your kiddos, okay? Oh, I like how I put two D's in kids, like your goats or something, okay? And then the independent variable would be the parent, because the parent is independent, right? They're taking care of themselves, they're supporting themselves, versus the dependent child that ends up having the parent take care of them. So in this case, independent is the thing that you input, and the dependent is the thing that outputs. So whatever it is that you're putting in, inputs, they're usually the x values, versus outputs, which are usually the y values, when it comes to left and right and up and down in a grid. Alright, so a little application here. The table shows the average temperature for 5 months in a certain city. We need to find the rate of change for each time period. So we're going to find the rate of change between 2 and 3 months, 3 and 5 months, 5 and 7 months, etc. And we want to find out during which time period did the temperature increase at the fastest rate. So the first thing that we would do is identify the dependent and independent variables. Remember that the dependent variable is the one that kind of is the output, or the y, and the independent is your x. So our independent variable is x. X is usually time, because time, does not depend on much. So in that case it is very independent, and so our independent is the month. And then our dependent is going to be the temperature. Alright. So taking a look at breaking this problem down, we want to find the rates of change. So if we're going to find the rates of change between 2 to 3, the change in the temperature from 2 to 3 was 0. And the change in the month was 3 to 2. And so we had 0 change over 1 month, which solved to be 0. The next one, the change in the month, goes from 3 to 5, but of course we want to keep these in positive values as much as we can. And then looking at our temperature change from 3 to 5 over those 2 months, we go from 56 to 63. So 63 minus 56 makes 7, and so 7 halves, or 3.5, was the change in temperature. The next one is 5 to 7, so we have another 2-month gap. And between 5 and 7, we have the numbers 71 and 63. So 71 minus 63 is going to make 8, and 8 over 2 is 4. And then our last one has a rate of change that changes in 1 month period, and our numbers go from 71 to 72. And so we have a difference of 1 degree. And so remember, they were trying to find out which time period did the temperature increase at the fastest rate. And so the fastest rate is going to be the largest number. And so between 5 to 7 is the fastest rate. Then they want you to graph this data, and they give you a graph already, so that's nice. You can see, as we talked about, our time is on this x-axis. Usually it is the one that is the independent variable, and then our y is the thing that responds to what month it is. So looking at our first coordinate, if we imagine these as coordinates, our first coordinate is 2, 56. So going over here, we're going to go over 2 and up 56. Looks like they go up by 2's, so this would be 56, and this would be 60, etc. The next point is going to be 356, so over 3 up 56. The next one is 563. And it doesn't have a point necessarily, but it would be halfway between 62 and 64. Then we have 771. Again, halfway between 70 and 72. And then 872. Whoops. And so hopefully you can see very clearly that there's no change here. There's quite a large change here, quite a large change here as well, and then here. And of course the steepest one was between 5 to 7, so this was the steepest growth. What else did they say? Oh, and show the rates of change. So they actually want you to say what number it would have been. So here's the rate of change of 0. This one, I believe, was the one that was, 3.5. This one was a rate of 4, and this one was a rate of 1. Alright. So if all the connected segments have the same rate of change, then they all have the same steepness and together form a straight line. And of course, because it was only off by 0.5, these two start to look like a straight line. And so the closer that they are, and of course if they are exact, they do in fact make a straight line, which is what this is saying. So the constant rate of change is then called the slope of the line, because it won't change as long as it is constant. So looking at this line, hopefully you can see that between each of these points, we end up going up and over the same amount. Up 3 over 2, up 3 over 2, up 3 over 2, and that is what we call the slope. The slope comes from, other than calling it dependent and independent, it comes from a rise over a run. And so again, previously we had talked about them being dependent and independent, and so our rise ended up being the dependent, and our x ended up being the independent. So we're talking about how much do we rise over how much do we run, and then that fraction is the slope. They also say these phrases of change in y, and that's because you end up doing subtraction, as we saw in the previous slide. So over here, change in, because we were talking about subtraction. And then here we are, we showed it up above, but remember y is the dependent variable and x is the independent variable. So we're going to find the slope here, and the easiest way to find slope is this idea of rise over run. So if we identify 2 points on this graph, we can just see how much do we rise and how much do we run. If you rise up, you have a positive number, and down is a negative number, versus if you run left or go left, that would be a negative number, and if you go right, that's a positive number. So just something that we look at when we're thinking about rise over run. To identify some points that will help us out, we do need to have grid lines that meet with the segment itself. So this one most definitely intersects each grid line as well as the line that's being graphed, and then this one as well. I would not want to use one of these points like this one here, because as much as that's on a grid line and it's on the line, it's not on one of the horizontal axes, and so it's very hard to predict what its exact value is. So instead, we're going to talk about how much we rise and run, always reading from left to right. So the leftmost point is this one, and so to rise, to get to the green point, we go down 1, and right 3. So thinking of what that means, down is actually negative, so negative 1, and right is positive, so just negative 1/3 is our slope. Another example here. Let's see, they gave us the points here, 5, -5, and 0, -3, so that is a little bit more helpful. But again, we're still going to do the reading of the leftmost point to the rightmost point. And we're going to be doing the rise over the run. So in this case, the rise is again down, and so we're going down 2. And we're going over 1, 2, 3, 4, 5 spaces to the right. And so remember, down 2 means negative, and right 5 means positive, and so -2/5 is the slope of that line. Meaning that to get from one point to the next point, you would have to go down 2 and over 5 every time. All right. Horizontal and vertical lines, of course, are completely, well, they're different, because, for instance, if I think about this point to this point, how much do I rise versus how much do I run? Well, in this exact instance, we end up rising 6 and running nothing. And so because it is actually illegal in math to divide by 0, we actually call this slope not a number, but the word undefined. Anytime that you are ever dividing by 0, doesn't work, and so we either have an error on our calculator or we realize that means that it's undefined. When it comes to the next one here, when we think about rise over run, notice that we, to get from this point to this point, would never actually go up. And so we're rising 0 no matter how much the number is. In this case it is technically, 12? But it doesn't matter because 0 over any number is a slope of 0. So, turns out all horizontal lines, which is what we have in this example here, have slopes of 0, and all vertical lines have slopes of undefined. So here we are, as shown in the previous examples, kind of coming up with what we have. A positive slope reading from left to right is going up. A negative slope, again reading from left to right, is going down. And as we just saw, a 0 slope is your horizontal line, and a vertical slope is your undefined. Sorry, vertical line is your undefined slope. One issue with, of course, thinking of these as up and down is that I can very clearly imagine this little guy running up this line, but it is the negative slope. So we have to be careful with that idea, and you have to remember that we are reading from left to right. So from left to right, if you're following the line, you're going down, versus if from left to right you're reading the line, you're going up. I know personally I had issues with that. I can think back to learning this and know that that was an issue. So left to right, up or down. Alright, so in this one we're going to describe the slope as positive, negative, 0, or undefined. So again, reading left to right, if I follow this line, I'm going up, and so up is positive. Same idea here, reading from left to right, starting at the leftmost point, going down, and so because we're going down, this is a negative slope. Alright, our last examples, we're telling if this is positive, negative, 0, or undefined. This first one here is undefined. Flipping back to our notes here, if we had a vertical line, it was undefined. So we have undefined slope. And then over here from left to right, we're going up, and so that's a positive slope. Alright, and so that is it for our 4-3 notes. So hopefully we have a little bit of an idea of rate of change. Again, rate of change is the same as talking about dependent and independent variables in a fraction, but also rise and run in a fraction.